Hey there, class. Mr. Pusky here. Hope you're having a good day so far. We're continuing with one of the last sections of Chapter 8, which is 8.6, identifying special quadrilaterals. So this whole section is about using our kind of quadrilateral flowchart and kind of identifying what shapes meet certain criteria and also identifying what shapes they are, okay? So let's get right into it here. So we have quadrilateral ABCD has both pairs of opposite sides congruent. What types of quadrilaterals meet this condition? Why don't you guys, in a second, you're going to pause the video and think about which ones would do this. But remember, you're looking for, on the way the flowchart works is the things at the top of the flowchart have these criteria or these properties, and everything below that thing on the flowchart is going to also have those properties, okay? Why don't you guys go ahead and see if you can figure out which quadrilaterals meet this condition. Okay, I believe that this comes from parallelograms, right? Parallelograms have this condition, but what shapes are also parallelograms? Well, we also have a rhombus. Rhombus. Rectangles are also parallelograms, and squares are also parallelograms. Okay, so those are all shapes that meet this condition. Okay. All right. How about checkpoint 1? See if you can figure this one out. It says quadrilateral JKLM has both pairs of opposite angles congruent. Which quadrilaterals meet this condition? It's actually going to be the same exact shapes. Okay, those are kind of all properties of parallelograms here, okay? All right, sounds good. Example 2, what's the most specific name for the quadrilateral ABCD? So it looks like we have 4 sides congruent. That's all we know about the shape. Why don't you guys see if you can figure it out? The only shape that has 4 sides congruent is a rhombus. This is a rhombus. It looks like a square, but we need a square to also have rectangle properties, which means that all angles are right angles. We don't know that. Okay. All right. Identify a quadrilateral. Is there enough information in the diagram to show that quadrilateral FGHJ is an isosceles trapezoid, and explain? All right. Well, we know that both pairs of base angles of isosceles trapezoids are congruent. So these are both congruent. We need to show that these are both congruent here, right? So this should also be 78. We're not sure, though. But we can figure that out by doing x equals, and we can do 180 minus 102 to see if it matches, right? And what's 180 minus 102? That equals 78 degrees. So this is going to be 78 degrees, so we can say yes, both pairs of base angles are congruent, okay? All right. Okay, checkpoint 2. Why don't you guys see if you can do both of these, 2 and 3. Give them a try. All right, what's the most specific name for this quadrilateral? Well, we can see these are congruent. They're both 7, and these are congruent. Yeah, what shape has consecutive sides congruent? That's going to be a kite. All right. Very cool. And then checkpoint 3, it says, is there enough information in the diagram to show that quadrilateral BCDE is a rectangle? So this would be here. So we have to show that's a right angle, right? Well, we can show that these two are going to add up to 180. So we can do 180 minus 90. And that does equal 90 degrees. So we can say, yes, we have 4 right angles. That makes it a rectangle. All right, kind of a short and weird lesson today. That's all I have for you. Thank you for watching. Have a great day, and we will talk soon.